There is a point so far from Earth that sunlight no longer feels like home. A place where the solar system thins out, where the sun's power becomes a memory, and where human technology should have died long ago. But one spacecraft is still there, still awake, still sending signals back across the dark. Voyager 1 was never supposed to make it this far. It was built for a short mission, a quick tour of the outer planets, a few years of work, and then silence. Instead, it kept going, past Jupiter, past Saturn, past the edge of the sun's protective bubble. And now, in the emptiness between the stars, it is hearing something no human being has ever heard directly before. A faint, persistent hum vibrating through interstellar space itself. Not a voice, not a message. Something stranger. The background resonance of the galaxy. Voyager 1 began as a mission with modest expectations compared with what it became. Launched in September 1977, it was supposed to spend a handful of years visiting Jupiter and Saturn, photographing them, sending back data, and then fading into irrelevance as its job ended. No one designed it to become the farthest human-made object in existence. No one planned for it to survive nearly half a century. And yet that is exactly what happened. Part of that miracle came from timing. Roughly every 175 years, the outer planets line up in a way that makes a rare grand tour possible. A spacecraft can use one giant planet's gravity to sling itself toward the next, conserving fuel and gaining speed. Voyager 1 and Voyager 2 were built to exploit that extraordinary alignment. It was a once-in-many-lifetimes opportunity, and NASA took it. Even early in the mission, Voyager 1 was already exceeding the boundaries of what it was supposed to be. Just days after launch, from millions of kilometers away, it turned around and captured the first photograph ever taken of Earth and the Moon together from deep space. It was a subtle clue about what this mission would become. Not just a machine gathering data, but a witness carrying humanity farther outward than anyone had dared to expect. Voyager 1 did not become legendary only because it survived. It became legendary because of what it found on the way out. At Jupiter in 1979, it confirmed that the Great Red Spot was not just a colorful feature, but a giant storm larger than Earth itself, raging for centuries. It discovered Jupiter's ring system almost by accident. It found new moons. And on Io, it saw something no one had ever seen beyond Earth before. Active volcanoes erupting in real time. Then came Europa, with its smooth, fractured icy surface that looked uncannily like broken sea ice. That image helped ignite one of the most important ideas in planetary science, that beneath Europa's frozen crust there might be a hidden liquid ocean, a possible habitat, a second ocean world in the solar system. Voyager 1 was supposed to be flying past planets. Instead, it was opening questions about life beyond Earth. At Saturn, it did the same thing again. It revealed that Saturn's rings were not just a few broad bands, but thousands of delicate ringlets shaped by moons in motion. It transformed Titan from a mysterious orange blur into something much stranger. A world with a thick atmosphere cold enough for methane to behave the way water does on Earth. Methane clouds, methane rain, a chemistry that should not have felt familiar, yet somehow did. And when mission planners chose a trajectory that let Voyager 1 study Titan closely, they made a sacrifice that changed history. They sent the spacecraft permanently out of the plane of the solar system, giving up further planetary exploration in exchange for something unprecedented, a path toward interstellar space. For decades, scientists imagined the outer boundary of the solar system as a broad, gradual transition. The sun constantly emits a flow of charged particles called the solar wind, inflating a giant protective bubble around the planets known as the heliosphere. Beyond that lies interstellar space. The assumption was that the boundary between them would be diffuse, slow, and hard to define. Voyager 1 found something else entirely. In August 2012, the transition happened abruptly. Solar wind particle counts dropped sharply. Galactic cosmic rays surged. The magnetic environment changed. Over about 2 days, Voyager 1 crossed from one domain into another as though it had passed through a membrane. Not a haze, not a gradual fade, a boundary. Thin, sharp, and far more defined than scientists expected. It was the first time in history a human-made object had entered interstellar space, and what it found there was not emptiness. The interstellar magnetic field was stronger than expected, pressing against the heliosphere with much more force than models had predicted. In other words, the galaxy outside the solar system was not quiet and passive. It was pushing back harder than we knew. The sun's bubble was not expanding into emptiness. It was holding its shape against a far more structured, more forceful interstellar environment than anyone had realized. Among all of Voyager 1's discoveries beyond the heliopause, one is stranger than the rest. Between 2017 and 2020, it detected a steady, low-frequency hum at around 3 kilohertz. Not a burst, not a flare, not a one-time event. A continuous background tone, faint but persistent, resonating through the plasma between the stars. This was not sound in the ordinary sense human ears would hear in air. It was a plasma wave oscillation, an electromagnetic vibration moving through the ionized gas of interstellar space. But the effect was extraordinary because the frequency encoded something real and measurable, the density of that plasma. For the first time, humanity was not merely theorizing about the medium between the stars, it was measuring it directly from the inside. Voyager 1 was effectively listening to the local electrical resonance of the galaxy, and that is what makes this so haunting. The spacecraft is not just drifting through darkness. It is moving through a real environment, one shaped by ancient supernovae, magnetic fields, charged particles, and the lingering structure of a vast local bubble in interstellar space. The hum is not a message intended for us. It is the universe's own ambient whisper, the electrical murmur of the medium our solar system has been floating through all along. No human had ever directly measured that before. Voyager 1 did. What makes this story even more extraordinary is that Voyager 1 has no right to still be functioning. This spacecraft was built with 1970s technology. Its memory is tiny by modern standards. Its systems were never intended to survive half a century in deep space. And yet here it is, more than 24 billion kilometers from Earth, still sending information home using a transmitter with roughly the power of a dim household bulb. By the time that signal reaches Earth, it is unimaginably faint, almost swallowed by the cosmic background, and still our instruments can hear it. That survival has not come easily. NASA has been shutting down instruments for years, sacrificing anything non-essential to keep the most important systems alive just a little longer. Then, in late 2023, something went wrong. Voyager 1 began transmitting nonsense, corrupted, undecodable telemetry caused by a memory failure in its flight data system. At that distance, even diagnosing the problem felt almost absurd. Every command took about 22.5 hours to arrive. Every answer took the same amount of time to come back. One conversation with the spacecraft required nearly 2 full days, and yet engineers fixed it. They rewrote old software, rerouted code around the damaged memory, broke unified instructions into pieces that could fit into the healthy parts that remained, and sent the repair across 24 billion kilometers of space. After nearly 45 hours of waiting, Voyager answered with coherent telemetry again. It was a resurrection on a timescale and a distance that barely feels human, and because of that resurrection, the spacecraft remained alive long enough to keep listening to the interstellar hum. There is another layer to all this that makes the mission feel almost mythic. Voyager 1 is not only a scientific probe. Bolted to its exterior is the Golden Record, a gold-plated disc carrying images of Earth, greetings in dozens of languages, music, natural sounds, and tiny encoded fragments of what it means to be human. Rain, surf, thunder, birds, a mother speaking to her child, Bach, Beethoven, Chuck Berry. Not because NASA expected aliens to find it anytime soon, but because humanity decided that if something of ours was going to leave the solar system forever, it should carry evidence that we were here and that we understood the significance of reaching outward. That is what makes Voyager 1 feel larger than a machine. It was sent on a short errand and became an emissary. It revealed volcanoes on Io, oceans beneath Europa, the chemistry of Titan, the true edge of the heliosphere, and now the ambient resonance of interstellar plasma itself. It crossed the membrane between the sun's domain and the galaxy beyond, and instead of going silent immediately, it kept reporting back, still listening to a place no human being will reach for a very, very long time. And maybe that is the deepest reason this hum matters so much. It is not just a signal from interstellar space. It is proof that humanity has finally put an instrument into the galaxy itself and kept it alive long enough to hear what that place sounds like. Not metaphorically, not poetically, physically, measurably. Voyager 1 is no longer just leaving home. It is teaching us what home is surrounded by. So in the end, what Voyager 1 is listening to is not a message in the science fiction sense. It is something stranger and, in many ways, more profound than that. A steady plasma hum resonating through interstellar space itself. The electrical whisper of the medium between the stars. The quiet background voice of a region of the galaxy no human being had ever directly measured from within before. Voyager did not just leave the solar system. It crossed into a place that had only existed in models and theory, and then it began reporting what that place actually feels like. That is why this matters so much. Because Voyager 1 was never supposed to become this mission. It was built for a few years of planetary exploration, and instead it became humanity's first surviving witness to interstellar space. It rewrote our picture of Jupiter, Saturn, Titan, Europa, the heliosphere, and now the local plasma environment of the galaxy itself. And somehow, with 1970s hardware, fading power, and signals so weak they barely reach Earth at all, it is still listening out there, still hearing what no human has ever heard before. And maybe that is the most haunting part of all. Voyager 1 will eventually go silent. Its power will drop too low, its instruments will shut down, and one day the spacecraft will stop speaking forever. But even then, it will keep moving outward, carrying the golden record through the dark, farther from the sun, farther from Earth, deeper into the galaxy than anything we have ever sent. Long after the last transmission ends, Voyager will still be out there, drifting through the same hum it was the first to hear. A tiny human machine listening to the universe until it no longer can. If this changed the way you see space, subscribe, turn on notifications, and stay with us. Because the farther Voyager goes, the stranger and more beautiful the universe seems to become.